Transitioning a little bit into schema and partition management. So this is outside of the architecture of the table format, but this is a very powerful and difficult thing to manage in the data lake. So schemas and partition management are typically very static in a data lake. So you can add and drop columns, but you can't really change any types. You can widen a type. You can go from an integer to a big integer, but that's about it, right? And it really supports standard types, like integers and strings and things like that. But nested types are much more difficult to evolve. You have to write a lot of custom code to make that work. If you do want to make any changes, you actually need to rewrite your data files. And this is very painful and costly problem. And along the same lines, it has strict partition layout. As you can see in a diagram I showed below, you kind of define your partitions as, for example, like a year, month, and underneath those folders, you have your files. But what if you wanted to go from a year, month, and company ID? Like, you can't do that, right? Once you've written your files into your folders, you're done. You can't add any more. So if your query pattern changes where your user says, I want to select star where company ID equals 1, well, you can't leverage partitioning anymore, right? Because partitioning is only done based on date. So it's very strict partitioning in the data lake. If you do want to add another partition, you got to rewrite, redistribute the data, copy it. It's very costly operation on the storage layer. Lakehouse basically takes a lot of the schema and partition management and moves it from the physical layout of the data and the folders and puts it into a manifest, into a set of metadata files that are much easier to manage and update. So schema evolution, nested and complex types like arrays and maps and structs are supported. You can change your names, you can add a column, remove a column. You can do a lot of things like that, all by updating the manifest, the metadata file, and do not need to touch anything with the physical file. So you don't have to rewrite anything. Changing data types is a little bit harder. It's not actually supported as well in the Lakehouse format. It is something in the future, but currently it's not that flexible. Guarantees correctness. So actually in Iceberg in particular, each column has a column ID in addition to its actual column name and details. So when you're making changes, right, you don't step on top of each other. What if you deleted a column name customer, and you add a new column named customer? Like, you're not going to step over each other. You're not going to expose old data or data you're not allowed to see. So it's very flexible, and that it kind of gives you that correctness. Partition evolution, as you can see in the diagram below, maybe it's a little hard to see, but basically you can add new partitions. So if you start with year and month, and now you want to add customer ID or company ID or something like that, you simply add it, and it gets added into the manifest. So when the query engine goes to filter that data, it asks the manifest file, hey, I'm looking for rows that are within year 2023, month 1, company ID 5. The manifest, the metadata file, will return the results. The query engine doesn't have to scan data in S3. So it saves you a ton of time, a ton of processing, and it's much faster for the query engine to ask the metadata layer as opposed to the data layer. And then similarly with sort order evolution, if you want to resort your data in a certain way, you can change that sorting, and then any new data that gets inserted will use that new sorting. So it's actually speed up your querying.